Hello, pre-calc students. We're going to continue talking about Chapter 7 today, Systems of Equations and Inequalities. We're going to continue and actually finish up Section 7.1. Last time we looked at these first four things, defining what a solution is, solving using substitution, solving by elimination, and looking at systems that don't have just exactly one solution. And today we're just going to focus on this last thing, solving problems using systems of linear equations, also known as word problems. Yay! Woo! I love word problems. Oh my gosh, me too. So here we go. So for word problems, I think one of the toughest things for these types of problems is setting up the system of equations. So that's what we're going to focus on, is actually writing the equations. So here is a very timely example. I did not do this on purpose. A chemist is working on a flu vaccine, and they need to mix a 10% sodium iodine solution with a 60% sodium iodine solution to obtain 50 milliliters of a 30% sodium iodine solution. So how many milliliters of the 10% solution and of the 60% solutions should be mixed? So the general idea here is we have two different unknown values, the amount of this and the amount of this that are needed to be combined. Those two unknown things are going to be the answer to this question. And those two things you should define as your variables. So those two unknown things should be your variables. You can use whatever letters you want. I'm going to use X and Y. So your first step is define your variables. Once you've done that, you're going to write equations based on what you know. And for this problem, there are basically two things that we know about what we get when we combine these things. The first thing we know is that we want exactly this much when we're done. And the other thing we know is we want it to be this strong or have this percentage. So I'm going to write one formula for that, and I'm going to write one formula for that. The formula for the 50 milliliters is actually pretty straightforward. How do I get a total of 50 milliliters? Well, when I add together these two values, the number of milliliters of this plus the number of milliliters of this should equal the total number of milliliters. So this one is as simple as just x plus y needs to be equal to 50. Now the next equation is a little more complicated because it's dealing with like a percentage. All right. So when I combine these two things, I want it to be this strong, or have 30% sodium iodine. So here's how that works. Basically what I do is I take this amount of milliliters multiplied by its percentage and add it to this amount of milliliters by its percentage. So my equation is going to be a 10% of x plus 60% of y. Now you'll notice here's the left side of that equation, 10% of x plus 60% of y. Now this side is I think the hardest part of this equation to come up with. But basically the way I think about this is I have a percentage times a number of milliliters, and I have a percentage times a number of milliliters, which means on this side I should also have a percentage times a number of milliliters. A lot of times people just write the 0.30 here and don't multiply it by 50, and then they do not get the right answer. So make sure you're matching the same format. Percentage times milliliters plus percentage times milliliters should be equal to another percentage times milliliters. Okay. So that's how you set up a system of equations for this type of problem. Now solving this, I'm not going to go through all those steps. We did that yesterday. You can use substitution or elimination. I'll assume you know how to do that. When you're done, you should get those two answers. So you should still try solving that though, and do make sure that you get those answers. All right, let's take a look at another example. So here we go. With the current, a motorboat can travel 84 miles in 2 hours. Against the current, the same trip takes 3 hours. Find the average velocity of the boat in still water and the average velocity of the current. So here's the idea: is the boat, when it's going with the current, when the current's helping it travel in the direction it wants to go, it takes less time. When it's traveling upstream, it takes more time. That's the idea. All right. So the two numbers I'm trying to find are the velocity of the boat and the velocity of the current. So those two numbers, again, my first step is to define variables. Those two numbers are going to be my two variables. Those are the numbers I'm trying to find. So x is the velocity of the boat and y is the velocity of the current. Then I'm going to use this equation here, this formula that says velocity times time equals distance. This is something that I hope you remember from, like physics and past math classes. And basically, I'm going to write a formula that has this, or an equation that has that form for these two different trips. I'm going to write one equation for when it's going downstream and then another equation for when it's going upstream. So you can see when it's going with the current, I'm going to write a formula here, and then when it's going against the current, I'm going to write a formula here. So what that looks like here, when it's going with the current, which of these numbers do I know? So that means it's going like downstream. Which of those do I know? Well, I know the distance is 84 miles, so that's going to be an 84. I know the amount of time that it takes is 2 hours, so that's going to be a 2. And then what's going to be its velocity? Well, the velocity of the boat is unknown. I don't know what the velocity of the boat is. But when it's going downstream, it's actually going faster than that because the current's helping it. Like if it were going, like 30 miles an hour, but the stream was going 10 miles per hour, you would say that, well, then it's traveling actually 10 miles an hour faster than 30 miles an hour, which would be 40. So to find the velocity, whatever these two numbers are, though, you add them together. So when it's with the current, you get to add the typical velocity of the boat with the velocity of the current to get a faster velocity. Now, when you're going against the current, it's going to be a very similar thing. Oops, forgot my time sign there. It's going to be a very similar thing. The distance, it's still the same trip. It's still an 84-mile trip. Okay. And then the amount of time it takes, though, is longer. I'm given that it takes 3 hours. So the amount of time here is going to be 3. And then this time, though, when it's going against the current or upstream, it will go slower. So basically, if it typically goes 30 miles an hour, but it's fighting a 10 mile an hour current, it's, the actual speed of the boat will be reduced by that 10 miles per hour. So to find the speed of the boat when it's going upstream is x minus y. And those are going to be my two formulas there. There they are again. What am I looking for? Here we go. So then what I do is I take, these two formulas and I distribute the 2 and I distribute the 3. And that gives me this system of equations. Personally, I would use elimination to solve this, using, making them 6y and negative 6y and then add them together, solve for x, plug that back in, solve for y. I'm going to assume you know how to do that. You should give that a try and then check your work. You should get that x is 35 and y is 7. That means the typical speed of the boat is 35 miles an hour and the speed of the current is 7 miles per hour. Next, our final word problem here. A company that manufactures running shoes has a fixed cost of $300,000. Additionally, it costs $30 to produce each pair of shoes, and they are sold at $80 per pair. Write the cost function C of producing X pairs of shoes. So how much does it cost the company to produce shoes? Well, they have this fixed cost, and then they additionally have this cost. So my equation will incorporate both of those things because you can see they are both costs to the company. So basically, this is the price or the amount it costs them no matter how many shoes they make. And then this is the additional cost for every pair of shoes. So that's going to be the fixed cost of $300,000 plus 30 times X, where X is the number of shoes that they make. Then I'm going to write another function for revenue. So revenue is the amount of money they make from sales. And you can see that their revenue is $80 per pair. And that's it. So pretty straightforward there. It's just 80x. So R of x is 80x. And then last, determine the break-even point. What's the break-even point? Well, the break-even point is when the revenue is equal to the costs. After they are making more money than they're spending, they are then making money. The break-even point is the point that happens at. So here's just kind of some language here. You can think about it's called profit if you do your revenue minus your costs. And the break-even point is when the profit is 0. Okay? So the break-even point is when we go from, a negative profit to a positive profit. So that break-even point is when that's 0. And that happens when these two numbers are the same. So one way to think about the break-even point is that's when the revenue is equal to the costs. So to answer this question, I'm trying to find the time when the cost formula is equal to the revenue formula. So all you need to do is plug in your equation for cost there and your equation for revenue there, and then solve that equation. So you subtract 30x, you divide by 50, and you get 6,000. So the break-even point is when they sell 6,000 shoes. So you can see that my system of equations were these two equations, and then basically this step I'm using substitution to set them equal to each other and then solve. Notice that I just found how many shoes I need to sell. If I wanted to then figure out what the values of cost and revenue would be, I would plug that 6,000 into either one of these equations, and I should get the exact same thing from both equations. That's why it's called the break-even point. So pay attention to the question that's being asked so you know which of those values you are being asked to find.